Hi students, in this video we are going to discuss about the problems on the block brake. So let us consider a problem. A single block brake is shown in the figure. So the drum diameter is 250 mm, the contact angle is 90 degree. If an operating force of 700 newtons is applied at the end of the lever, the coefficient of friction is 0.35. Determine the torque that may be sustained by the brake. So if you observe the given sketch, first you have to identify which condition it belongs to. So from the sketch you can clearly see that F theta, that is tangential force, is above the center of the fulcrum and the wheel. So you have to consider that condition when you want to select the equation for the applied force. So you have to consider both the sketches, that is for clockwise as well as for the counterclockwise direction. So when the wheel is rotating in a clockwise direction, F theta will be acting away from the fulcrum. So you have to take the equation for counterclockwise. When the counterclockwise wheel is rotating in counterclockwise direction, F theta will be acting towards the fulcrum. So you have to take the clockwise equation. So coming to given data, so they specified A, the distance between the fulcrum and the center of the wheel, so that is 200 mm, B will be 250 mm and C will be 50 mm. And the angle of contact they given as 90, that is 2 theta is equals to 90, which is greater than 60 degrees. So you have to calculate the equivalent coefficient of friction. So D, diameter of the wheel they given as 250, so therefore R will be equals to 125 mm. And they given the mu, so 0.35, and F is equals to 700 Newton. Since 2 theta is greater than 60, so I want to find out mu dash. So mu dash is given by 4 mu sin theta divided by 2 theta plus sin 2 theta. So substituting all the values over here, I want to get mu dash as 0.385. So this will be calculated only when 2 theta is greater than 60. So for a clockwise rotation, so F theta will be acting away from the fulcrum. I should consider the counterclockwise formula from the table. So you have to go for the table 19.1 and condition C you have to take, that is figure C. So for a counterclockwise, I want to get the formula as actuating force F is equals to F theta into A divided by A plus B multiplied by 1 by mu dash minus C by A. So by substituting all the values, I can find out the tangential force F theta. So F theta I want to get as 70.954 Newton. So torque, we know the formula, torque is equals to, that is mt is equals to F theta into R. So F theta is already calculated, R is given. So I want to get torque as 83,869.3 Newton millimeter. If I consider the counterclockwise rotation, so F theta will be acting towards the fulcrum, so I should take the clockwise formula. So again from the table 19.1, condition C, the formula will be F is equals to F theta A divided by A plus B multiplied by 1 by mu dash plus C by A. Substituting all the values of F, A plus A, B, mu, C, I want to get F theta as 553.136 Newton. So once you got that value, calculate the MT, that is the torque value with the formula F theta into R. So I am going to get 69,142 Newton mm. So if it compare both the conditions, the clockwise rotation gives the more torque. So that will be the capacity. So torque capacity of the given brake will be 83,869.3 Newton meter. So let us take the next problem. A block brake shown in the figure is to balance a torque of 500 Newton meter on a drum at 1000 RPM. Assuming the coefficient of friction between the brake shoe and the drum is 0.25 and the contact will be less than 60. Angle of contact will be less than 60. Determine the tangential force on the shoe, the normal force on the shoe, force F applied to the brake for clockwise and counterclockwise direction. The dimension C is required to make the brake self-locking, assuming the other dimensions remain the same, and heat generated. So these are the things you have to calculate from the given problem. So when you want to observe the sketch, first you have to identify the condition it belongs to. So from the sketch it is clear that F theta lies between the center of the wheel and the center of the fulcrum. So I have to consider the second condition. So when you want to go for the second condition, so you have to consider either it is moving towards the fulcrum or away from the fulcrum. So whenever the clockwise rotation of the wheels takes place, F theta will be acting towards the fulcrum, so I have to take the clockwise formula itself. Whenever the wheel is rotating in a counterclockwise direction, F theta will be acting away from the fulcrum, so I have to consider counterclockwise formula for the calculation. So data is given as what? A is given, B value is given, C value is given, and diameter of the thing is given, that is the wheel. and empty torque they given as 500 Newton meters, so they are going to convert into Newton mm, and n value is given, that is 1000 rpm, and mu is given as 0.25, and they specified 2 theta is less than 60. No need to calculate the mu dash value. Going for the tangential force on the shoe, so that is the torque formula. We know that mt is equals to f theta into r. So mt is known, r value is known. I can calculate the tangential force. So f theta is equals to 2000 Newton. So coming on to the second step, the normal force. So we know that Fn is equals to f theta by mu. So f theta is already calculated in the previous step, and mu value is given. So I want to substitute the values. So I want to get Fn is equals to 8000 Newton. Coming to third, that is the third step, applied effort F for a clockwise and counterclockwise rotation. So previously I said, since for the given problem, the clockwise rotation of the wheel gives f theta towards the fulcrum, so I have to consider clockwise formula itself. And the condition is second condition. So from the table 19.1 figure B, so I am going to take the clockwise formula. So that is F is equals to f theta into A divided by A plus B multiplied by 1 by mu minus C by A. So substituting all the values, I am going to get F as 1900 Newton. Similarly, if I take the counterclockwise direction, f theta will be acting away from the fulcrum. So from the table 19.1, condition B, I want to use counterclockwise formula. So actuating force, F is equals to f theta into A divided by A plus B multiplied by 1 by mu plus C by A. So by substituting all the values, I want to get F is equals to 2100 Newton. So the dimension C required to make the brake self-locking, assuming the other dimension remains the same. That is the fourth condition they asked. So when you go for that condition, we know that for self-locking, effort should be lesser than or equal to 0. So by taking the condition on a clockwise direction, so f theta A divided by A plus B 1 minus mu minus C by A is greater or less than or equal to 0. Or I can say that 1 by mu should be less than or equal to C by A, or you can say C by A should be greater or equal to 1 by mu, or C should be greater or equal to A by mu. So from this case we know that A value will be 250 and the mu is given as 0.25. So C should be, when you want to simplify that one, the C should be having equal or greater than 1000 mm. So if C is greater or equal to 1000 mm, then the brake will be a self-locking. So coming to the next one, the area has to calculate the heat generated. So heat generated Hg is equals to mu P AC into V. So P is the pressure, A will be the area of cross section. So together it gives you Fn. So I want to substitute that as Fn. So mu Fn into V. Substituting all the values. V I want to substitute as pi dn by 60,000. So I want to get heat generated as 52,359.88 watts, or I can say that one as 52.36 kilojoules per second. So coming to the next problem, a single block brake with the torque capacity of 15 Newton meter is shown in the figure. The coefficient of friction is 0.3 and the maximum pressure on the brake lining is 1 Newton per mm square. The width of the block is equal to the length of the length. Calculate the actuating force, dimension of the block, resultant inch pin reaction and the rate of heat generated if the brake drum rotates at 50 rpm. So you can take the sketch over here. So if you take the f theta over here, so f theta will be resting above the fulcrum as well as the center of the wheel. So I have to consider the third condition for calculating the actuating force. So by taking the clockwise rotation, when the clockwise rotation goes, f theta will be acting away from the fulcrum. So I have to consider the counterclockwise direction formula. So given data has been entered over here. So I will go for directly as actuating force. So mt is equals to f theta into r. So mt value is given, that is the torque value is given. So f theta I want to get as 100 Newton. So for actuating force F is equals to, so since it is having the third condition where f theta is lies above the fulcrum as well as the center of the drum, and it is whenever the clockwise rotation it have to go for the, it is acting away from the fulcrum, so I have to consider counterclockwise formula from the table. So from table 19.1 figure C, counterclockwise formula F is equals to f theta into A divided by A plus B multiplied by 1 by mu minus C by A. So I want to get F is equals to 93.33 Newton. Going for the next one, dimension of the block. So normal force Fn is equals to P into projected area of the block, that is P into L into B dash. So B dash is nothing but the width and L is the length. So when you're going to go for, in the problem they given B dash is equals to L, so I'm going to substitute that, and Fn I'm going to substitute as mu f theta. So I'm going to go for that. So I'm going to go for substituting that values. I'm going to get as L equals to 18.2574 mm, or I can say that L will be equals to 18.26 mm. So the width of the shoe will be 18.26 and length of the shoe will be 18.26. So resultant pin reaction. So when you go for that, I have to calculate both the Fx and Fy values. So when I go for normal force Fn, so Fn I'm going to get as 333.33 Newton using the formula F theta by mu. So when you're going to consider the vertical forces, there will be three forces acting, that is Fy, Fn and actuating force F. So Fn will be acting away against the F value. So I want to take F plus Fy minus Fn equals to 0. So I want to get Fy is equals to 240 Newton. Similarly, go for horizontal forces. I want to get only two forces, that is F theta and Fx. So both will be acting away opposite side. So Fx will be equals to 100 Newton. So resultant hinge pin reaction will be Fn is equals to, Fr is equals to root of Fx square plus Fy square. So I am going to get that one as 260 Newton. What is the heat generated? So heat generated formula again, Hg is equals to mu P AC into V. So P into AC I am going to replace with Fn and V with the pi dn by 60,000. So I am going to substitute the values. So I am going to get as 78.54 joules per second. So this is about the problems.